Just gonna yank it. Okay. But that's quite okay from my point of view. Tell me, is this on? Yeah. And is Mateo? Do you see any online participants, namely Mateo, Paul Wolfram, and Luis Martinez? Can you give a hey, Mateo, Luis, Paul, if you can hear us? Or see us? Okay. I texted him. I know he's coming. Winning. Do you have Luis's? Can you text him and just text? I mean, okay, good. All right, good. Then I think we can begin. Okay. So, great. Thanks everybody for coming. This session. So I'm David McCollum. Research scientist at Oak Ridge National Laboratory, previously was here at YASA, so it's really nice to be back. Paul Kishimoto, who's co-chairing this session physically. We also had a number of other colleagues who were helping to organize this session. Sonia Ye, in particular, who's at Chalmers University, who sadly couldn't be here. I mean, she just had a conflict. That's all. She's no COVID or anything, as far as I know. Boz, of course, is involved, but he's busy with everything at the meeting these days. And Roberto and Jonas, who are also helping us to plan this over the past several months. So it's great to finally be at this point after a long time. I think we have a really good session lined up with a lot of diverse speakers. Hey, Celine. Hey, Charlie. Don't get out of here, Charlie. What are you doing? we don't need any hecklers at the back. So the session is about transport, and as you can see in the title, namely about bridging communities that do different kinds of transport work, different kinds of modeling, who do work at different scales. You don't have to be an expert in transport to join the session, or I think to be interested. We really wanted to use, I know there are a few. Yeah, what? Hey, you know more than you think, and that you let on. We really wanted, just to use transport as an illustrative example for, again, using scenarios to help, bridge community scales and to do more work in the future, thinking towards the next cycle of scenarios in IPCC, but in other contexts as well that are far outside of the IPCC, right, in national context, for instance. So that's the objective here, and we've got 5 great talks lined up. Let's see. Hold on a second. Okay. This is a workshop session as opposed to the research talk session, right? And so that means the goal is really lots of discussion, okay? So we have short, relatively short presentations, 10 minutes for 3 of the speakers, 7 for a couple others, and then this will hopefully leave, about half the session available for talking, for discussion. First among the panelists, and Paul and I will help moderate that, but then with the audience as well, and even crossways discussions, right? I mean, I think we can be quite flexible and casual here. And this session is, as far as I know, not being live streamed, so it's it's us here, and the only people that are online are those ones I was naming earlier, who are just the 3 who are part of the speakers. And so those speakers include the 5 that you see listed here who are giving oral presentations: Roberto from the Federal University of Rio de Janeiro, and Guining, who's here, who's presenting, who's from the International Transport Forum in Paris as part of the OECD, and he and Luis Martinez prepared their talk together, but he's online. Mateo Muratori is a colleague in the U.S. I work a lot with him. He's at both the U.S. Department of Energy and at National Renewable Energy Lab, and he's online. I believe he's online now, isn't he? Paul, cool. And Ramya Natarajan, who's at the Center for the Study of Science, Technology, Policy. What is the E then? Is it not energy or environment? No. I was wondering this yesterday. Okay. I got it right. Good. And then Rafael Garrafa, from the European Commission, the Joint Research Center, who just arrived just in time, just now, which is great. So I'm going to pass it, now to Paul Kishimoto here, who's going to say a few words, with that framing rationale, how we got to this.
Thanks so much, David. Thank you all for coming here and being here for this discussion. So, just to reiterate, I wasn't actually fully up on this, so I just learned about this weekend myself, but all of the materials for the presenters are on EASA Connect, right? So if you navigate to the program, you can click through to this session, and then you can see who the presenters are, and you can click through their individual profiles. Their slides are there. Each of our presenters has given us a 12-minute recording, which is longer than the time that they'll have here to speak. So more detail about their work is there for you to listen to. And as well, particularly for the poster presenters that David mentioned, their posters are there. There's an interactive mural board, so you can leave comments on specific parts of their posters or ask questions. And I think Paul Wolfram has also left a recording speaking to his poster, just like he would live if he was able to be here in person. So I'd really encourage you to do that later today, back at your hotel room, later in the week, whenever you would like, and take your time to digest and absorb and really get into the meat of what people have been doing. So just as a point of introduction, we're dealing with systems of systems, right? So we know that mobility happens at a human scale. And the attainment of access and all the other SDGs and goals that we're concerned with happens to each individual person, right? At the same time, we're concerned with global and long-term attainment, especially of climate targets, right? So we entered into this very difficult task of modeling, assessing, analyzing through scenarios, through data, a very large complex system of systems. And sometimes we will go into the detailed view and resolve the subsystems, the phenomena, the different modes, the different types of vehicles, the different fuels, etc., the different transport systems in different parts of the world. And at other times, out of necessity, we're forced to take aggregates and look at lower resolution, more aggregate concepts, things of that nature. So what we'd like to, so the example on the right is you can look at the systems within a particular electric vehicle. You can look at the electric vehicle and its particular fuel supply, or you can look at the broader energy system in which that electric vehicle operates, right? So what we're really concerned with today in this session is as different teams do research on transport systems, parts of the global total transport system, focused by geography, focused by mode, and are interested in looking at specific phenomena that are affecting those systems, secular change, certain types of policy, behavioral change, new technologies, new business models, all of these things, right? How can we bring this together? How can we bridge, right? And so we know that it is one system in the real world, but we take very different approaches to modeling and to constructing scenarios with which to understand it. And so what I'd like you to look at going through these presentations is how do we do this in a more seamless way and a more fluid and flexible way, where we are producing insights through our scenario-based research that allow us to come to a coherent or mutually reinforcing understanding of what should be done and provide insights of policy relevance. Okay. So we go to the presentation. So I believe first up is Roberto, and we will get your slides up. So again, the first two presenters have 10 minutes. I'll give you a 2-minute warning, a 1-minute warning, and then I'll hold up a bright red thing when it's your time. Okay? So there you go.
Okay, thank you very much. Hello, everyone. My pleasure to be here. It's my second in-person presentation, I think, the past almost 3 years, so it's a pleasure to be here. Basically, what I'm going to be presenting here, or I'm going to try to put 3 pieces together. So we have been doing some work on international aviation. We have been doing some work on international shipping. And we have been doing some work on, let's say, mitigation scenarios at the national level. And basically, the answer I'm trying to answer here, to what extent, let's say, trying to build scenarios for these three different realities, aviation, shipping, and, let's say, a well below 2-degree country, to what extent we're talking about the same thing or not. And basically, this is what we want to explore here, whether or not there are some synergies between these different approaches, aviation, shipping, and a country compliance with pledges. The focus here is basically on, let's say, possibility of some synergies between aviation and shipping or not, simply because, let's say, we have been doing some studies on how a country can comply with IATA, let's say, pledges of reducing emissions by 50% by 2050 as compared to 2005 numbers. In a different road, let's say, how a country can comply with IMO, let's say, targets of reducing emissions by 50% in 2050 as compared to 2008. So basically, let's say, instead of producing scenarios for aviation, producing scenarios for shipping, to what extent we're talking about the same kind of scenarios that using an integrated model can end up with some interesting results. The first thing, let's say, is important to have in mind, because I'm going to be showing results here from an integrated assessment model. What are the possible technological routes to produce aviation fuels, to produce, let's say, shipping fuels? So basically, there are different possible routes here, and I'm going to explore that. Also, let's say, by using an integrated model for Brazil, is the BLUES model, this is how we represent those different technological routes in our model. So basically, we have possible routes coming from crude oil, possible routes coming from, let's say, animal fat, oil seeds, or hydrogen, etc., etc. So this is basically the things that we're going to be playing here. And also the possibility, and we have this in our model, of co-processed biomass in oil refineries, which also adds an additional dimension to the issue I'm going to be presenting here. Okay, what about scenarios itself? So in the case of aviation, we have been playing with different possibilities for scenarios for aviation. Let's say we have to take into account historical data, we have to take into account income elasticities, GDP, travel demand in terms of passenger kilometer, travel demand for freight. So many, let's say, possibilities here. And also, when you try to forecast or build a scenario into the future in the case of aviation, should we consider COVID, no COVID, let's say a recovery from COVID in the V-shaped recovery, U-shaped recovery, L-shaped recovery? So many dimensions here. Let's say, what kind of scenario should we explore here? In the case of shipping, similarly, let's say, it's difficult to forecast how international trade will behave into the future. Let's say low demand, high demand. In the case of Brazil, let's say more than 70% of the fuel used for international shipping rely heavily on iron or crude oil exports, soybeans, sugar. So even we have to model or have scenarios for these different commodities in order to be able to see how demand in the future will behave. So different possibilities when we design scenarios here, let's say, as I mentioned, let's say, different aviation demand scenarios, shipping demand scenarios, different climate policies that can be, let's say, deal with at domestic level, IATA pledges, IMO commitments, aviation fuel efficiency, so many dimensions here. And so basically we have a kind of combinatorial explosion, and we have to play with that. So what we decided to do here? We decided to focus on 4 different scenarios. Let's say a IATA-only scenario, a IMO-only scenario, a IATA IMO, meaning that you meet both scenarios at the same time, and a scenario that only looks at a Brazil below 2 degrees. And basically we want to see to what extent, let's say, we have some superposition between these different scenarios, or if they are completely different. And also, I'm not going to go into details here, we had some sensitivity cases here. Let's say, in the case of IATA IMO scenario, let's say, if you have, let's say, if Brazil becomes a major exporter of kerosene for aviation, or in the case of IATA IMO, whether or not biomass to liquids, small plants become commercial more shortly, and the same applies to the case of the well below 2 degree scenario for Brazil. So I'm not going to go into details here, but this is a sensitivity case important because, let's say, small biomass to liquids plants are much cheaper than big ones. And you already have biomass to liquids plants available today, but you don't have the big ones. So if you put that information in a integrated assessment model, that model will always choose the big plants. But because those plants are not available yet, we decided to have a sensitivity case here with small plants as well. Also, I'm not going to go into details here, but in this sensitivity about Brazil becoming a major kerosene exporter, in fact, different integrated assessment models has already shown Brazil as a potential exporter of biofuels. So that's why our sensitivity here is not that crazy. Okay, what about results? So results here, if this figure is simple, but I have to explain what does it mean exactly. Based on what we show here, let's say, what are the international aviation CO2 emissions coming out of Brazil? So if you follow a IMO-only target, which means a target for shipping, of course, emissions from aviation will go up because IMO does not have anything to do with aviation. So that's why IMO scenario only have higher emissions for aviation, and all other IATA scenarios or IATA IMO or even a well below 2 degree Brazil, you see much lower emissions for aviation in the case of Brazil. Similarly, in the case of shipping, if you have a IATA-only scenario, which has nothing to do with shipping, then you see much higher emissions from shipping and much lower emissions in the case of IMO or IATA IMO with kerosene export, etc., and a well below 2 degree Brazil. Okay, and in the case of a well below 2 degree Brazil, as expected, let's say we see not much impact on IATA and IMO emissions, but major emissions on total emissions from Brazil because, again, it's a scenario for well below 2 degree Brazil and not a scenario to meet IATA or to meet IMO targets. Okay. What about the picture for aviation fuels in Brazil in 2050 according to the different scenarios? So this is interesting and calls the attention of the importance of an integrated kind of approach because we see the profile of fuels for aviation being completely different depending upon which scenario you talk about. If you focus only on IATA, you have one profile of aviation fuels. If you focus on IMO, which has nothing to do with aviation, a completely different, let's say, profile. If you try to meet both IATA and IMO, a different profile. Then if you have Brazil becoming a major exporter of kerosene, a different profile. And when you see a well below 2 degree Brazil, the profile of aviation fuels is completely different because basically have integrated model that's try to optimize the entire energy system in Brazil, where aviation fuels become a byproduct of that system and not the main product. I'm not going to go into details here. I won't have less than 2 minutes now. The same applies to shipping. Let's say, the profile of shipping fuels in the case of Brazil is completely different depending upon if a IATA scenario, IMO scenario, IATA IMO, or Brazil well below 2 degree Brazil, etc. So this is the message here, let's say. It is very difficult for you to have a scenario for one sector without taking into consideration the other sectors, because at least in the case of fuels like this, you have byproducts. When you produce a kerosene for aviation, because it's such a high-quality fuel, as a byproduct, you have shipping fuels. So basically, you cannot think only about one or the other. You have to have a really integrated approach here. So this is the answer we're trying to answer. The question we try to answer is there is a synergy between these scenarios, and somehow I don't have time here to show more, but for sure there are synergy between those sectors and also implications in the case of land use. I'm not going to go into details. My 2 final slides here. Let's say scenarios development is most useful for the exploration of complex problems. Fuel switch is key to mitigate greenhouse gas emissions in both aviation and shipping sectors. From a IAM perspective, drop-in biofuels are most promising alternatives for these sectors in the short term. So, as expected, let's say some synergies do exist between these two sectors. But, let's say, if Brazil became a major exporter of kerosene for aviation, in that case, let's say the synergy would be much, much greater because in order to produce aviation fuels, you're going to have a huge amount of byproducts that can be useful for shipping. So, to a certain degree, we can say that there are some synergies in here. We also show that biomass to liquids and ATJ kerosene plants produce significant amounts of bunker fuels. And basically, just to end here, in sum, let's say, what we're trying to show here is that our scenarios have shown to be able to serve as a common language for discussing the phenomena across subsystems, facilitating integration of distinct modeling and outcomes. So this is basically the main message here. 30 seconds pass. Thank you very much.
Thank you so much.
Yeah, so next is Gwening and Luis. Yeah. Yeah, I mean, he should unmute himself. Luis, can you say hi?
Hi, everyone.
Yeah, so that's one Luis Martinez may want to speak up at any point during this presentation. But, I think
Thank you.
Okay, great. All right. Thank you, everyone. So my name is Gwening Chen from the International Transport Forum at the OECD. So it is a great pleasure to participate in the Scenarios Forum. It's my first time. And it's my first time in YASA, despite working with you guys already for a long time. So very happy to be here. So Luis, my colleague Luis Martinez is online. So we prepared this slide together. It's titled Integrate Transport Models for Assessing Cross-Scale Common Scenarios. So without further ado, let me get started. So implementing sustainable development policies and requires very connected actions across multiple sectors. For example, Paris Agreement. To reach the Paris Agreement climate change goals, it is a perfect example of how policies and actions must be coordinated across different scales, like local, national, regional, and global levels to deliver the goal together. So scenario development is a commonly used approach to test the impact of different policy measures on the complex and uncertain future. However, it is challenging to develop a set of cross-scale scenarios, common scenarios that fully link the narratives and quantitative models of different sectors and scales. So at the ITF, we have been putting quite some efforts in addressing such challenges. For example, over the past 10 years, we have developed a set of ITF modeling tools, including global level, local level, regional level, for covering all the sectors at different geographical scales, and we try to unify them under a single framework. So this is the set of the tool that we use to adopt, to test different policy scenarios and to present to our member states. So our counterparts in the countries are Ministry of Transport. So we are trying to give them, using this quantitative analysis to give them evidence-based policy recommendations. So let me give you a short overview about the modeling framework that we have in-house. So we have 4 major global models, so urban passenger, urban freight, interurban passenger, interurban freight, covering global regions. But under each of these categories, we also have different scales. So built from case-specific policy analysis at the country level or at the local government level, and sometimes at the regional level, for example, Central Asia, Southeast Asia, or European Union, etc. So we have different multi-scale models in-house. So the logic is we start from building forecasting the demand. So what is the global demand in different sectors? So taking into consideration the socioeconomic characteristics such as GDP, demographics, and also the trade activities, etc., and taking these assumptions, and then we would forecast the travel demand in different sectors, and we would leverage different policy measures and exogenous factors into splitting these travel demands into different modes. So trying to capture the modal behavior for different sectors. And then once the demand is split into different modes, then we will compute passenger kilometers traveled, ton kilometers traveled, and then split them into vehicle kilometers traveled, and eventually convert them into CO2 emissions and other local pollutants. And we also, in the model, we try to integrate other type of indicators as well, for example, accessibility and connectivity and reliability or resilience of the systems as well, in order to be able to answer different questions. So here, just to give you a quick example of how we actually integrate the, or communicate between the city level or national level urban models and the global urban passenger models. So as I mentioned before, at the city level or the national level, we have done a lot of studies, for example, the micro-simulation type of studies for Lisbon, Auckland, and Dublin, Lyon, Helsinki, etc. And we also have this meso type of model for Baku, Tashkent, Ulaanbaatar, Bogota, etc. And we have the national model for different countries like India, Azerbaijan, and also the regional level, European Union, for instance. So what we did is actually we always build these models from a detailed level, but we pass the estimated elasticities and the urban typology differences from the lower level to the global level. So the global level will actually always maintain, capture the local differences, their urban typologies, and then the distributions, elasticities are we making sure that they reflect at the lower level that we obtained. And then the global model always preserves the regional differentiations and the local insights. So just to give you, for example, a quick example, like we did in the shared mobility study for Lyon and Dublin, etc. And we, for example, we identified these detour factors. So that for shared mobility, that actually gives us a very good insights about this deadheading for shared mobility services or taxi services. So we will actually be able to capture the percentage of deadheading in those kind of components and apply to the global level for other cities. And then here is another example, the parameters that we got. So from the shared mobility model, we can actually pass on to the calibrations of the global model. So the impacts of introducing full shared mobility on the modal share. And then this shows a parameter that we obtained from the detailed simulation study about CO2 per inhabitant, and then these are the indicators that can give us a very good range of variation. So we can adapt this to the global level, adapt to different regions of the world, and to estimate the potential impacts of the CO2 emissions for shared mobility services. And then in the freight sector, we also did similar thing. We also did the regional and national freight model. So here, the regional and national case studies that we did, or the models that we built, actually provided a very good, accurate data in terms of transport supply and performance in the specific regions, and this would help us very much in calibrate our global model better in reflect those specific regions and also specific countries. And some of the policy measures tested specifically in the country will actually give us a feedback about the how other regions would actually react to different type of policies, and then we would design their penetration level, etc., differently, differentiate them by different regions. So this I will not go into detail. It's just a dashboard that we presented to the Ministry of Transport in Argentina. So we built a national freight scenario building dashboard for them, and also integrating this with the global figures so that they can play with it and see what is the global impact and what is the impact specifically for the Argentinian freight sector in terms of CO2 emissions. And by inputting different combinations of policy scenarios, what could be the impact of reducing the CO2 emissions from their freight sector, and what is the implication actually for the neighboring countries and the regions as well. So that's also another way of interacting between our different level of models in the freight sector. Okay, so now I just gave you how the model interacts. Now I will give you a quick summary of how we design the scenarios. So in the cross-scale design scenario design process, we always follow the same logic. So we always start from stakeholder policy survey be it at the national level or local level or regional level, and with similar type of questions. And then getting insights from them. And the second step will be to do really the evidence research ourselves and conduct stakeholder consultations and expert judgments to identify a list of effective policy measures and their impacts on the model. And then the third step is to really integrate them into the scenario, into the model, and then to refine the scenarios. And if it's reflecting the assumptions or not, if it's reflecting the observations or not, then we tune the scenarios until it reaches convergence. So exactly 10 minutes, but I will just quickly give you a very brief summary of what we did in the study. So basically, one thing I would like to highlight is really the first one. So the macro decision models, for example, mode choice components, etc., they really integrate the detailed statistical distributions and elasticities, and we bring them into the higher level context whenever possible. And then the higher level will actually maintain the regional differentiations. So thank you very much. This was a quick presentation. Thank you. So feel free to check out online. Yeah.
Thank you, William.
So what I'm told is that I guess due to connection issues, we're going to just have Mateo's recording displayed.
Well, I think that's the standard for all the.
Oh, okay. Okay, so we're just going to... are you playing this or I'm playing this? Okay, go ahead. Yeah. Also no sound. Mm-hmm. Yeah, it's true. Mateo, are you online? Can you unmute yourself and say hi, if so? Possibly not. Should we move on to one of the next ones while you figure that out?
It looks like I'm talking and my microphone is working, but can you guys hear me?
Yeah.
Oh, awesome. Hey, Paul, thanks for confirming. I'm not sure if the room is hearing us, though.
Yeah, the room is hearing you. We're good.
Okay.
I have.
Perfect. Let me know what you prefer to do, and wish I could be there in person. Good to see a full room of people.
Yeah. So what we have is we have your video recording loaded up here, but they have not loaded up your plain slides. So I can play the video, and the video will run through, and you should be able to see it. And then you could just speak as it advances. Would you be prepared to do that?
I can try. It's going to be a little bit hard to follow on the video. Do we want to take a pause and see if there is someone in the room who can go live and see if we can make the video work? Because the video can have audio as well. This is Matteo Muratori.
Oh, I wish I think we now have it working. Yeah, so the AV tech.
Perfect. Let it go.
Yeah, we'll just play your recording now.
That we do in person today to talk a little bit about decarbonizing transportation systems. I am from the National Renewable Energy Laboratory, or NREL, one of the U.S. Department of Energy national labs. We all know how important energy is for our lifestyle. Think about comfort and services in buildings, efficient industry manufacturing, communications, and of course, mobility. However, today's energy system is heavily reliant on fossil fuels, which has major social and environmental implications. What you see here is the breakdown of energy use in the United States pre-COVID-19 pandemic. You see about 80% of energy coming from fossil sources in the US. Today I'll focus on the top bar that you see there on the right-hand side, transportation. This is about a third of all our energy use in the US. And perhaps not surprisingly, there is a very heavy dominance of petroleum fuels, that red bar that you see up there. We rely on petroleum for over 90% of our transportation energy needs. Transportation is the least diversified energy sector. As a result, transportation is the largest source of U.S. greenhouse gas emissions. It overcame power sector generation to be the largest source a few years ago. And transportation is also responsible for about 50% of total energy expenditures and is largely responsible for local air pollution. Of course, this was considered one of the hardest sectors to decarbonize, but we think that story is changing, and I'll talk a little bit more about that today. But before we dive into that, I wanted to point your attentions towards the breakdown within transportation. Transportation isn't a monolithic block. We have passenger cars, and then trucks, and medium and heavy-duty vehicles, and buses, and off-road vehicles, and trains, and ships, and airplanes, and a lot of other applications. So all these different modes of transportation and these different applications will require different solutions to it. The long-term strategy of the United States establishes a goal of net zero greenhouse gas emissions by no later than 2050 and 50 to 52% emission reduction by 2030. As you can see, the sense of urgency to act is high, and we need to start implementing solutions to decarbonize all of our economy right now. Transportation in this study is projected to remain the largest source of emissions until about the 2040s, but it is on a pathway to 80 to 100% emission reduction by 2050. So we want to explore a little bit what does that pathway look like. And when I think about decarbonizing transportation, I think that there are 4 key trends that we really need to keep in mind and focus on. First, mobility is evolving. Think about sharing, think about automation, think about telepresence that became so relevant nowadays. This is how I'm giving this talk. Think about micromobility. Also think about all the heterogeneities of peoples and market and places and how they influence decisions and technology adoption. That's really important to fully understand. Of course, vehicle electrification is a critical trend, as well as integration with the greater energy system. Transportation is not going to be a silo anymore moving forward. And we need to keep in mind and focus on all of these elements when we think about decarbonization pathways for transportation. A few years ago, we published a literature review study where we really tried to understand what were the modeling implications of these changes. And we boiled it down to fundamentally 4 elements. Really being able to capture these emerging trends. Keep in mind the locus of choice when we think about these heterogeneities and the central role that households play. Increasing the spatial temporal resolution to capture energy system integrations when it comes to future transportation system, as well as capture the multi-sectoral dynamics that are unfolding in the energy system in general. As a result of this, we decided to create a new model called TEMPO, the Transportation, Energy and Mobility Pathway Options. In Tempo, we lay the framework to really try and understand how new technologies and business model can disrupt mobility. Think about sharing, think about mobility as a service, think about connectivity and automation, as well as new modes of transport and emerging fuels and powertrains. So we really try to keep the modeling flexible so that we can capture some of these disruptions that are happening in our mobility systems. We also try to capture the fundamental drivers of mobilities and where choices are made, which we think is fundamentally done at the household level. And so you see here, for example, smaller, low-income urban households have a very different travel behavior from larger, middle-income rural households. And they also use very different modes when they satisfy their mobility. The reliance on light-duty vehicles, for example, is a lot higher in rural areas versus no-energy modes, and public transit is more largely used in urban areas. And so we want to be able to capture these nuances that are really important to understand how mobility is going to evolve. We also want to capture how vehicles are used differently within households. For example, in a two-vehicle household, which is about 33% of total households in the U.S., their primary vehicle is driven 2 times as much as the second vehicle. Different vehicle classes also have very different fuel economies. So we really want to understand how different households choose different vehicles and how do they use these vehicles. And this is largely going to determine both energy use, vehicle needs, for example, what is the range that is required of different vehicles, as well as then the emission implications that result from different choice. And going back to our third driver, vehicle electrification is really disrupting transportation. And EV will have far-reaching consequences for electricity systems as well. These are some results from our Electrification Futures study, or EFS. And what you see there is that we projected by 2050, transportation will make up for the majority of load growth opportunity in the U.S. And transportation will grow from being less than 0.3% of electricity demand today to almost a quarter of total electricity consumption in 2050. And when it comes to electric vehicles, it's not just important to understand how much electricity is going to be needed. It will also be critical to understand when and where EV charging will occur. This is extremely important from a power system perspective. While when we think about fossil fuels, what really matters is how much we are going to consume. When it comes to electricity, charging an electric vehicles at midnight or at noon and at 2 different locations is going to have very different implications for the power systems. So we felt that a new class of models was needed to assess the integration opportunities of electric vehicles with the power system and capture this spatial temporal resolution that is really critical from a power system perspective. Also keep in mind that vehicles are part for about 96% of the time in the U.S. when it comes to personal vehicles, and for a very long period of times when it comes to commercial vehicles as well. So there is a huge opportunity to manage EV charging to both satisfy the mobility needs but also support the grid. We see a tremendous value that can be untapped by managing EV charging that really enables synergistic improvements of both the efficiency and economics of mobility and electricity systems. Transitioning to our fourth trend, while today transportation systems rely primarily on a single fuel, petroleum, we think that the future is going to have a combination of different fuels. Electric vehicles will be critical, but we also see very important roles for low carbon fuels like hydrogen or sustainable biofuels or e-fuels as well. So after over a century of petroleum dominance, what we envision is a future transportation system that will be optimally integrated with smart buildings, the electric grid, other infrastructure, and this will really enable to fully leverage and support clean energy and achieve an economically competitive, secure, and sustainable future for everyone. This is a list of references and studies that we published over the last few years on these topics, and I encourage you to check them out if you're interested. A lot of, or most of the data underlying these studies is also publicly available, and if you can't find it, please do send me an email. We are always more than happy to share underlying data and results from our studies with everyone. Here is my contact, and I'll take on this opportunity to congratulate NREL for our 45th anniversary, and I look forward to the discussion with everyone later today.
Great. Thanks. Thanks to the recorded voice of Matteo. Okay, so next we have Ramya Natarajan from CSTEP. And Ramya and Rafael will have to have the lovely challenge of giving a 7-minute presentation, but I'll give you the same time hints, and we'll give you some more time during the Q&A.
Yeah. So hi everyone, I'm Ramya from the Center for Study of Science, Technology and Policy, CSTEP, where the E stands for nothing. And I'll talk today about a couple of models that we've been using at CSTEP, but not get into the details of the assumptions, but just about how we're thinking about this. Just to start with some context for India, this slide is to show you that the transport growth in India is going to be massive up to 2050. And so this is because of income and also, you can see this extreme shared mobility and sustainability is not really because of policy, but more out of desperation and poverty. So even as we go along and we may have efficiency improvements in the fuel, we're going to have drops in efficiency when you look at per passenger kilometer traveled because of people now being able to afford their own vehicles. Even the vehicle ownership is really low. So at what level is this going to saturate for India is a very important metric to estimate emissions, and we don't really know what that estimate would be because we just make multiple scenarios. So this is, if you've spent sleepless nights thinking, what is this transport sector, contribution to Indian emissions? So we just have this pie chart here that shows that intercity, road, and freight contribute to the most amount of emissions in India, and it's mostly from road. So the two models that we've developed, the first is SAFARI. Again, it's not the perfect acronym, but it stands for Sustainable Alternative Futures for India. And this work was, initially inspired by the Decent Living Standards work, and we started with what is required for a decent quality of life in India, and we started quantifying the development goals, so different types of sustainable development goals, food for all, housing, healthcare, education, and then we mapped the energy and emissions out of the implications of that through that, so that we're not looking only at GDP as the driver of growth. But we got stuck at a point where there are industries that are not directly linked to any quality of life goals. So then we had to then go back to a little bit of GDP. So our model now has multiple drivers, and most recently, it's probably one of the youngest models in the AR6 database housed at EASA. We've constructed multiple scenarios. We've also contributed to India's declaration of net zero, so those scenarios that the government wanted. The other model we use for transport is the discrete choice model to see what influences people's behavior towards selecting a particular mode versus another. And there we use different parameters, not just cost, because we actually found that there are other parameters that affect people's choices more. So this is just a graph on some of the emission implications of some scenarios. I'm not going to spend too much time on this, but as you can see from my, when I first said that the transport sector emissions are going to keep growing, that's the reference scenario that shows this. And it's going to take a lot of effort to even just keep it at today's levels because of this growth in just the activity in transport. So even to keep it at today's levels, we have to electrify 100% of passenger transport and all of these, the shift towards rail, compact cities, these kind of scenarios. So one of the things about Safari and the other model is that instead of giving you neat solutions, it kind of asks you more questions. We had mapped out a bunch of these interlinkages, and I don't know if you can see my cursor. Okay, yeah, okay. So I'll just talk about the top left part of this. So we have a compact city scenario in the model where we see the interlinkage between buildings and transport in the urban areas. And we see that if you plan and there is compact city and if there is densification, in the Indian context, that means that buildings will have to be much taller to accommodate all of this population within that smaller area. So you save on land and you probably save on transport emissions, but you increase the demand for steel and other construction materials because per meter square you need more materials to construct taller buildings. And then there is also this operational energy that goes up along with urban heat island effects and all of that. So we found that this trade-off has to be looked at carefully if we want to have an efficient and well-planned compact city scenario. The other interlinkage story is with biofuels. So in India, we have a 20% ethanol blending mandate for 2030. I mean, it's been advanced now to 2025. And it has, as you can imagine, negative impacts on agriculture sector, water use in the agriculture sector, availability of water and stuff. In terms of electrification, I think Matteo spoke about this. Right now we don't even have 100% electricity in India. A lot of villages don't get 24/7 electricity. So massive scale electrification is a power sector problem that has to still be studied. In the modal share part, we found that people, of course, this is limited by the data that we could collect or use, primary data, but people were willing to shift to a more costly choice as long as it saved them time or it saved them, some other kind of benefit that it gave them, safety so it's not always all about the cost. And so we're trying to now look more into that aspect. So these are actually this is my final slide. We might discuss this more in the discussion section, but I just wanted to talk about in the first bullets, of course, the availability of critical materials and impact on the grid is one of the feasibility aspects of EVs, but also behavioral shifts. So if I save money by, I've been incentivized to take public transport, but what will I do with that extra money that I've saved? Do I take an extra leisure trip? And so, those rebound effects, how do we model? The kilometer per capita saturation level for India, different countries have saturated at a different level. And what is going to drive that in India? Is it going to be just GDP per capita? That's, and even if it is that, is it going to be at 15,000, 20,000? And the decarbonization levers that will be needed are very different depending on where it saturates. And, we have a lot of data issues, including just PKM. There is no consistent data on PKM for India. So every model that you see for India uses a different PKM starting PKM for 2018-19. So, yeah, so I think there are a lot of data issues that need to be looked at. So these are the contributors, and thank you.
Thank you very much, Ramya. Very efficient. So the last presentation that we have is from Rafael. And, you have a P. So you might have to look over your shoulder there. It's not mirrored. There you go. So 7 minutes. All right.
Can I close this? Where's the cursor? Okay. Okay. Thanks. Good afternoon, or good morning, actually, everyone. I'm Rafael Garrafa from the European Commission, JRC, site in Seville. Well, today, together with several colleagues at the Unit of Economics of Mitigation, I'm presenting really preliminary work that we just started on how to build baselines on air and land transport. So the main motivation to this work, and I'm kind of skipping the discussion on data gaps, and IAMs often miss a greater level of resolution, and it's something that is more or less known for the audience. But the main motivation is that within our unit, we have in-house models that really represent the transport model really at network level, type of congestion modeling, and all this origin, destination, really detailed information from these other colleagues, other peers. And we started trying to get closer to this, to the outputs of these models, and integrate them in our, let's say, more long-term kind of IAM modeling framework. So today I'm going to present a bit of really briefly the modeling toolbox that we use normally in our assessments, really preliminary results, and throw some questions for discussions, and that's more or less the structure of the presentation. So as I mentioned here, we have several models to kind of answer different questions. Our main modeling toolbox relies on energy system modeling, like the POSE-GRC model, which is a global model for the energy system. We also have the PRIMES model, which is more focused on the member state level. And then from this energy system modeling, we sort of integrate the outputs through a toolbox called Pyramid into the input-output format to project these I/O tables and use them in the CG in a computable general equilibrium model, which is the JRC geometry model. I'll talk a little bit more about the Pyramid framework. But the main idea is to bring, of course, consistency, economic consistency in our scenarios. Of course, when you have a partial equilibrium model like energy system modeling, like POSE and PRIMES, we're missing all the effects for the rest of the economy. So that's why essentially we use the CG model, which has been extensively used to produce baseline scenarios for impact assessments for the several GGs, and also for our global energy and climate outlook, the GECO, which we produce on a yearly basis. So I'm going to talk a little bit more about the way that we started doing this. Of course, there was some animation with the PowerPoint, but with the PDF, there's a spoiler already. We started with the energy that goes into this Pyramid, which is based on a RAS procedure. Essentially, for those that are not familiar, it's taking exogenous information and reconciliating into the I/O format, the matrix, so we can project those I/O tables in time and build a consistent baseline, as I mentioned. It sort of facilitates a lot the modeling work, let's say. So you don't need to go at really parameter levels and try to calibrate everything there. And then, of course, we go to the CG model calibration. As I mentioned, we started with energy. Then now this project, we are starting to look at the transport and trying to integrate this sort of information in the CG. Mainly using activity levels, PKN, TKN, data for transport from these transport models, and costs, average costs. Really at the EU level with really high detail, because we have lots of information at the member state level. And then for the main countries like G20 countries and OECD countries also have this sort of information. Showing you right now bit of really preliminary outputs that we want to have a deeper look in the following months. So these are essentially the supply side. We're looking mainly at the freight side of the transport freighted mode. And importantly, I skipped the initial part, but our main goal in this project is start disaggregating passenger and freight from the GTAP framework. So we are bounded by the GTAP, and I will mention it in the next slides. But just to show you a bit of the EU side outputs, and this is of course when we translate the variables from the transport models to the economic side, we are capturing that domestic production in monetary values. So that's challenging because how to measure that in a equivalent way using precise costs. That's one challenge. And the other one, of course, is to project these over time with all these new technologies coming and all these different mobility patterns arising. So here, of course, we can capture COVID effects. For instance, if we look at air passenger, we see in 2020 strong effects from the COVID, like in countries like Spain and Germany, but not for all countries. And now looking at non-EU countries, we have a couple of other results, really preliminary, also capturing the COVID effect. But for instance, Brazil, we have a strong share of rail freight being part of the total output of the sector. Next steps, we're going to look at households level, let's say, the consumer level, and look at more on the passenger side. So here I'm showing results for the freight. But before coming to my conclusions, I would like to throw a bit of points to discussion. The first is from the modeling perspective. Of course, there's always the discussion on bringing more detail into the modeling from exogenous information, rather than having it sort of a macroeconomic model decide based on elasticities and so on. So that's one point to discuss. The other one I will skip because probably Paul and David already did some gave us some great inputs on the discussion, and of course data gaps is one of them. But I would like to highlight in our case specifically, that we are constrained by the GTAP, so database. So that's one additional challenge in terms of data. And final, maybe a more simple question is the operation, let's say passenger and freight, this sort of split, is that useful? Is that relevant for climate policy assessments for the long term? Is something that the community really wants to look at, or shall we really keep the simple structure like by modes like land, air, and transport, without looking too much into that? My final slides, if I have 10 seconds, thanks. Just to mention that we project this input-output in time to build a consistent baseline for policy assessments. We take into account the projected activity levels and costs, as I mentioned. And next steps, we are looking at the maritime sector, which is not already split, and to build new baselines for calibration for policy scenarios. With that, I would stop here, and thanks a lot for your attention.
Thank you much. Don't go back to your seat. Please sit at the front. And Ramya and Gwining and Roberto, could you all come up? Thank you. So we're going to launch directly into the discussion to make the best use of our remaining time, if I can find the cursor. Yeah. David is excavating a mic. So we had prepared a number of rounds of discussion questions from us. I think what we might do is David and I will each introduce one round of these, and then we'll ask for one response from each of our presenters. Oh, sorry. Actually, before I go on, just a reminder: there's our two poster presenters. One is Eileen Lam from University of Macau, and she has a poster on the likelihood of the global EV tipping point, and then Paul Wolfram's is on value of hydrogen for climate change mitigation of the global transport sector. So please go and look at those online. So these are the questions that we had for our panelists. And specifically for those who are focused on specific geographies, specific countries or regions, what I'd like to hear from you is, are you able to look at data, methods, parameter values, stylized facts about the same transport sector phenomena occurring in other parts of the world, and incorporate those productively and usefully in your analysis? Is it easy or possible to make use of that? And if not, what stands in the way, right? So this is about integrating knowledge and using scenarios, methods, and data across different geographies. So I think there might be a different answer for each of you. That sort of leaves out the global models. So for Gwening, we have the question in your choice of linking between the city or regional or country scale models and the global scale model, I imagine that was not, your first cut of that linkage, and there was some effort and iteration to find out what quantities had to flow up and down. So if you could say a little bit about, in that sense, bridging between scales, what you've learned about what works and what doesn't work. And then for Matteo online, we have the question specifically about the household segmentation that was shown in the income, household size, and the urbanity or the urban-rural location. Which were those the first choices, or would you prefer to do something else? And is it data or some other experience that has driven you into the modeling and scenario design choices that you've made? So I think we would probably start with, let's say, from the right. So Rafael, Ramya, Roberto, and then Gwening, and then Matteo in that order.
Okay, thanks, Paul. Well, on your first question, I think we're still exploring the results, but of course the COVID effect is something that I highlighted in the presentation. I think that's something that I would bring back to the discussion, because if I look at one of the slides that I presented, you see Germany, Spain, but Poland, you don't see much of that effect. So that's from of course I'm not a specialist in Poland, but I would guess, okay, that should be the same effect there, because it affected all the economy. So this sort of as you mentioned, this sort of cross-regional impact I would expect to have there in Poland as well. So I would definitely need to deep into that country, go deeper and look what's going on there. And it's probably happening to other modeling outputs that we have there. So I think that's really useful in that sense. So when you have a big impact that you can compare across countries, that's really useful in terms of insights, and maybe there's an economy that the air transport sector is not that relevant, and so on. And that would be my.
So that there's not just one recovery globally, but there's a different recovery sort of happening in different countries.
Exactly. So when we translate into the economic outlook, let's say, we're sort of looking at the value of the sector, right? So if I don't know, it's probably not the case, but might be the case there where's a country that doesn't have a strong air company there. And then it's sort of reflecting our results, because in the end we are looking at the economic value of the sector. But of course I'm not a specialist on transport modeling, so I'm just looking at more on the economic side and the supply side.
Thank you. For Ramya, so you gave us a very good explanation of the sort of unique challenges facing the Indian transport sector and things that will factors in its evolution. So, looking across, low and middle income countries of the global south, some of those things are reflected, some of them are not, in very different and distinct ways. So, in your modeling and scenario design, Has it been useful, or is it possible to draw in some of those other work done in other countries, or is it more you're investing your efforts in covering those data gaps that you run into in India?
Yeah. So data, actually methods, and we've been able to use methods from other countries, but data has been more of maybe technical data for a particular technology that's coming up. But I want to give an example of the biofuel work. So the government came to us saying, can you do a cost-benefit analysis of the biofuel policy? And they cited this paper done for the US, where they found that prices of food increases, and they did a whole estimation very recently published in ERL and PNAS. So we looked at that. The thing about India is the agriculture sector is not market driven. It's heavily regulated, and so a lot of prices are regulated, sugarcane prices, and there's minimum support price. So we can't even replicate that work so the sectoral dependencies are very different in India. So while we're modeling, we find that a lot of these linkages and then how we model those sectors are very unique to India. So I would say that kind of bridging it is a big challenge. I don't see how unless we do developing countries of this kind, and then and also like the land required. So how people will behave. We will never reach a stage where every household owns like 2-3 personal vehicles, because there will just not be enough space to drive.
It's on a different pathway.
I don't know the answer, but yeah, something like that.
No, thank you. That's still very helpful. Can we pass to Roberto then? And then, similar question, right? So Brazil has its unique context, its unique economy, but to what extent do you learn and adapt from methods and data and approaches and scenario design approaches used elsewhere in the world?
Yeah, let's say all work we have been doing over the years is really, let's say, in-house developed. But of course, in order to be able to do that, we have to profit from other people's work. So we try to learn what other models do and try to incorporate into our models. In the case of data collection, let's say data for transport sector, at least for shipping and aviation, is quite good in Brazil. So we have been able to use real data from Brazil as opposed to try to adapt data from other realities. So there are other sectors that's more complicated to collect data, but in the case of transport sector, except for the issue of, let's say, transportation by income level at the city level is more complicated. But when you talk about shipping and aviation, as was my focus here, such that it has such a level of aggregation that the data that we have available for us is good enough.
Good. Okay, thank you very much. So then to Gwening, this question about the linkage, now not across geographies, but across scales, and your experiences in ITF in constructing that.
Yes. So I would just give a very brief intervention here. So maybe Luis online would like to jump in on this one.
Great, yeah.
Yes. Luis, feel free to jump in. So I would just speak about the comparability when we start selecting this cross-scale analysis. So we would always look at, finding a comparability between if we did a small, like a local level study, and then we would actually draw some kind of conclusions, and then we will actually look at the global regions in other countries, and then select the key indicators to use as a definition of defining whether this is a comparable case or not. So if that is a comparable case, then we could actually start adapting or transferring some of our findings in the local scale to the other region, and then so on and so forth. So the key here is really the comparability of selecting a comparable case. So I'll let now Luis to jump in and speak about the rest.
Yeah, thank you.
Yes, thank you, William, and thank you all. I think William described it quite well. We have like a type of decision tree on how to incorporate or equations or also parameters of or even in the policy design of adoption of different measures, considering that we have a set of variables that are defined as thresholds for belonging to that group, and then we have different scales which vary on the geographies, but also at an income level, and also to be considered as an homogeneous region in the world. And we are trying at least to have some data that is specific to that context that can be then extrapolated for the whole the whole group. And this is the approach that we have. In some cases, like in Africa, the absence of data, in our case, then it's a little bit higher. And we don't have any sometimes detailed case study that would allow us to extract this information. And this is the only case I would say that we are extracting for all other regions with the same levels of income level, but which we can also couple several things, not just the geography, and also, of course, especially if it's the scale, if the local context or the city, the urban and levels of urbanization, they are similar in different levels of different regions of the world, or in the intercity, if we have a focus on some specific availability of infrastructure that is available in the country, if it's very rail-based or road-based, etc. We try to have like a very sensitive design of like a hierarchical benchmarking technique for us to be using data from one context to the other.
Thank you, both of you. That's very helpful. Moving to Matteo. So this was the question. I mean, Matteo, you probably are in a position that everybody envies in one of the most data-rich environments in the world, right? Which, you know, it gives you a lot of things to do, but I'm sure it also still has its challenges. So similar to the question that Gwening and Luis were answering, in designing the particular representation in your tempo, in your framework, and the scenarios that you build on that, how have you been guided by, you know, the existing knowledge and desire to represent certain things, or stuff that's not, that you would like to represent but don't have a quantification for? And just an anecdote or two from your experience, please.
Yeah, I'll share a couple of thoughts. When we talk about the breakdown or the binning of different consumers into groups, we basically took a data-driven approach, and we tried to basically statistically analyze the data and see what were the most important variable. As you said, we are pretty lucky that we have pretty extensive data sets available, and so we didn't really make a preconceived notion that income or the region where you live were the major drivers of mobility. We just looked in the data, and we looked at gender, we looked at age, we looked at a number of other factors, and we found out that these three were the three most important factors driving mobility choices. Basically, how large is your household, where do you live, is it a urban or a rural household, and your level of income were the major driver of behavior when it comes to mobility. I'll also add another comment, because I think from a methods perspective, I've taken a lot from things that people in this group, as well as others, have done. Like David published a really good paper a few years ago on mobility that was quite useful. I think it's really relatively easy to leverage and look at methods across different countries. I think data is really challenging on the other hand. And when I think about transportation, I really break it down into two big buckets. There are decisions that are made by big companies, like airlines, and those are usually based on finance costs. So you only need to understand cost, or I shouldn't say only, it's pretty hard, but you understand cost and you can try and model those decisions. And then there are consumers, and consumers make these decisions in a very different way. So for example, we've been trying to look at markets like Norway, where they have a very high adoption of electric vehicles, and try to understand if that could be a look into how EV adoption could unfold in the US as well. But then we realize how different mobility is between Norway and the US, how different constraints you have, how different availability of public transit, and how people look at mobility differently, how Americans like pickup trucks and the ability of tow big boats, and how Norwegians have different attitudes when it comes to display their wealth and their sort of possessions. And so how do you factor those things in mobility? It's really tricky. It's really nuanced in a sense that the mobility that drive the decision to drive mobility are really personal and are really unique, and the feed they changes so much across different cultures and different parts of the world that the leverage in data gets really challenging. So I don't know if others have found ways and methods to use international data in other parts of the world, but we really struggle with that.
Yeah, excellent, Matteo. Yeah, thanks a lot. Appreciate each of the speakers presenting, but then also answering these really actually complex questions, because these are not easy. There are no easy answers. I think at this point we have 10 minutes left, and let's open it up to the audience. Personal questions. I know Gunnar has at least one. I'm seeing a couple other hands. One thing I want to just deposit out there is, we talked a lot this morning, and we will this whole week, about SSPs, RCPs. We didn't hear anything about that in this session, which I think Paul and I and the other co-organizers and the speakers are not surprised about. And this is a question for the community as we move to this next cycle of producing scenarios worldwide at different communities at all scales, from the global down to even the national and local. How can we do some of that better? And getting towards policy relevance, stakeholder relevance, the kinds of audiences that these folks at their institutions are working at. This is an open question. But Gunnar, maybe you had something else. It looked like maybe for Matteo. So go ahead.
If I may, two things. Like, first, on the SSPs, we have these discussions internally all the time, and I feel once you're at the sectoral level, you have to think in a different logic than the SSPs. It's just like there are different kinds of uncertainties, and there's limited ability to just kind of squeeze that SSP scheme to the kinds of uncertainty dimensions that you actually face for transport or buildings, or maybe also land use. But the other question that I have to the panelists, great talks. The one big challenge that I see is that there are, for the transport sector, there are a number of transformations that work on very different timescales. And there's like very fast-moving stuff, and there's the slow-moving stuff. And maybe we focused quite a bit on the not so fast-moving stuff, like these behavior changes, like decadal patterns of change. But then if you look at technology, I really think like there's huge disruptions, and every second year we have to update our model because everything has changed on the techno-economics. And I wonder, especially with electrification, given that this pace of change is so quick, and also that we might be relatively confident that in the long term we will be in a different electricity-based future, it's very, very hard to understand when this transition happens, how fast it happens. And it has huge repercussion also on the broader question of transformation. How do you think can we address that in our modeling and get this timing and the transition dynamics right?
Maybe let's take another question. Yeah, just get some ideas out there. Yeah.
Okay, so we'll take three.
Yeah, sounds good.
Thanks.
Yeah.
I appreciate all the presentations. I'm interested in the narratives that go along with them, because I think for transport we often focus a lot on technologies and data, and I'm missing a narrative that describes how that change looks in terms of what kind of future is going to look like, because I think it's a narrative that's been done very well by the car manufacturers, and that's still the dominant narrative, especially for passenger transport. So I don't know how we're going to get out of that one.
Great question.
Thank you, guys, for the great presentations. I just take the opportunity to say that today, just in 1 or 2 hours, my paper or our paper on food mile emissions will be out on Nature Food today. And on that one, we talked about localization, especially for global food consumption, and we sort of do the modeling and see that localization could reduce the emission to certain percentage. So my question would be, how do you guys think about localization, especially on the global freight mile emissions?
Did you have a question as well, Shirley? Let's just throw it in, and then each of the presenters gets a free choice of which one to answer.
Okay, so I had 2 short questions. One was already posed but wasn't answered, so I was wondering if I could bring that back. And the first question was really the SSP-RCP story. So is anyone really here looking at how the needs for adaptation will influence the transport sector and how that links with mitigation. So I'm just curious about that. And then the second was a question that was posed by, I think, one of the speakers, maybe I've forgotten which one, but this dichotomy between passenger and freight. Should we really be thinking always in those terms or not?
So all really good questions. Do we want to go in reverse order? Maybe start with Matteo and then Luis and then down here in the room. Very briefly, I guess a minute or so, whichever one of those struck your fancy or tickled your brain.
I mean, Shonali always asks really, really good questions, so maybe I'll take the very last one there. I do think we have talked about freight and passenger in a very separate way so far, but that's rapidly changing. Like, think about e-commerce and how it impacts then trip choices where, I don't drive to the store anymore. I just order something online and it shows up at my doorstep. And then I order 5 of those and I return the 3 that I don't want. And what does that mean for transportation? Does it increase freight? Does it reduce overall travel? Does it reduce emission and energy use? What's the net effect? So I think we have been thinking about freight and passenger in silos so far, and we are trying to break those silos, but it gets really, really complicated from a modeling perspective. So I think, I'm a modeler, right? So where my modeler said, I think the problem here is the level of resolution that we have in our model. In a global integrated assessment model, you can't explore those trade-offs. It's too detailed, it's too complicated, and we don't know how to do that. And so we go to all these overly detailed models to try and understand that, but we can only run them for a very small region. It takes years to run them, a lot of money, a lot of resources, a ton of data. And so I think here there is a little bit of a modeling gap, and we haven't quite figured out as a community, which way do we want to go and which are the feedbacks that we want to neglect and the ones that is important to capture. I think this one is one that we really, it's important that we capture it, but I haven't seen a good solution to do it.
Thank you. How about Luis? And then William is going to be here in the room so people can log him afterwards for further conversation.
Yeah, just to continue on Mateo's question on Shonali, I think that's a super good question. And for me, I have a different view than Mateo in the sense that, for example, we work much more on the policy analysis and not so much on the macro assessment models, either me or Gwyneth. And the problem is that if you don't separate and you don't understand how demand behaves, we are just relying that technology, it will be the one that drives that change. And if we don't have specific models, because the demand, either for freight or even on the scale, the sources of demand are completely different, and the solutions that can correct demand either in urban, on freight, or non-freight, or in urban freight or non-urban freight, are completely different. And if we don't are able to understand also the demand implications and just go to the technologies, just assume that there is no room for demand to change on this scenarios for the future. Thanks.
Very briefly, let me pick Gunnar's comment. In the case of ER5, it was interesting that I was involved in the chapter on transport. I was one of the 2 CLAs at the time. And since then, we're talking about, let's say, the transportation sector as a difficult to decarbonize sector. Yes and no, let's say. Why I'm saying that? Although we have very new technologies coming on, let's say, in the transportation sector, the average lifetime of a light-duty vehicle in OECD countries is 10 years. In developing countries, 20 or 30 years. So if you think about light-duty vehicles today, the global fleet is of more than 1 billion light-duty vehicles. So even, let's say, if electric cars are becoming more and more popular, to get to the point, let's say, to become important, this is going to take 20 or even 30 years. That's why, let's say, I think these technologies become important. But when you talk about mitigation or emissions, those technologies will not play a major role before 10, 15, or even 20 years. So that's why this, let's say, interesting discussion, but yeah.
So I can maybe talk about the adaptation mitigation question and also the narratives together, the question. So, like I said, Safari, we started with quality of life as the central driver. And so then, in sectors like agriculture, we've looked at both. The mitigation option is actually also the adaptation option, like changing away from water-intensive crops like rice towards millets. It's better for the farmer. It's more hardy, and it's not going to fall apart with the flood. So, in the transport sector, we're also, we now have a pretty strong adaptation team as well. We're looking at resilient infrastructure, and driving your car through a congested city is going to affect your quality of life versus, taking like a public transport or better non-motorized transport. So in that sense, I think the quality of life being the driver kind of helps us bridge the mitigation and adaptation narratives. So if we say, you go along with this kind of strategy, it improves your, overall life, I guess. So.
Very briefly, starting with Chonali questions. We did thought a bit on passenger and freight merging, and we had a good example on the air transport because we had an assumption on belly cargo, which is the cargo that is carried by commercial flights. So we kind of assumed, on average, 10% cargo being transported by commercial flights, which essentially would take EKMs, but then 10% of that would be TKMs. But that's just an example. Of course, it's really more challenging than that, and which takes me to the comment of Gunnar and maybe her comment as well on location and what from the macroeconomic perspective, of course, is much more when we're looking at long-term scenarios. We're looking at another time dimension, but we try to rely the most on the bottom-up detailed modeling information from the transport and energy sector. So that's our approach. Of course, it doesn't solve the question, but that's one take. We try to get the most information from that, and from that build. And of course, when we see some narratives coming up, of course, electrification, and coming to the last question of our colleague there on that side.
Would you like to wrap up?
Yeah, I think that was a good way to wrap up. Thanks to all the speakers. Thanks to everyone for coming. I think this was a really great session. We're just a minute or so over, but hopefully it was worth it. A good first parallel session of this long week. So thanks, everybody. Yeah, I think we have 30 minutes now, and we can chat a bit more with the speakers and others. So thanks. Thanks for those online. Thanks,
so the next session
Luis
starts in half an hour.
I think it's half hour. I think it's 4:30 to 6, and then poster session 6, 7:30. So great. Yeah, Luis, Mateo, if you're still there. I don't know, Paul, if you're there. Thanks so much. Yeah, it was a really good session in the end, and technically it worked out. So
thank you. Thank you.
We'll be in touch. Good deal. Thanks.